Bienvenue, amici, spal hair. No, I was going for salam alaikum. Yes, going for all the languages this morning, whereby all means I was trying for two and think I did like half of one. Um, I don't want that over there. That was silly. Right. So we have a bunch of red. We didn't make a whole lot of progress on Tuesday. Before the stream started, people were like, "Oh, the first one, second one, and fourth one are all easy." So let's see if we actually get to some non-reds today. All right. First up, improve host builder and web application builder configuration integration 61634. I feel like this is it's coming back. Stefan?
Yeah. So this is host application builder. It's already been approved. It's already been checked in. But then about a month ago, we approved use Windows Service and use systemd APIs for iService collection. They basically give you the right lifetime if you're running as like Windows or systemd service for your hosted application. I started a PR to add these new extension methods. And then decided that they had the wrong name, but are otherwise fine as far as public API goes. So instead of use systemd, I want it to be add systemd. And if you can scroll down, sorry, to the very bottom, that's the actual thing that I want to talk about right now. And then, yeah, add Windows Service instead of use Windows Service. And the reason for this is that it's an iService collection extension method. We typically prefix extension methods on iService collections with add. So it just looks a lot nicer. It doesn't stick out as much. The reason we went with use before is it was more similar to existing extension methods on iHost Builder, but this isn't on iHost Builder, so I think we can break that convention.
What would happen if someone called add on both of them?
It would basically, the last one would end up kind of winning the way service resolution works. If you did use Windows Service and add Windows Service, I might have to double check. You might double add a logger or something.
Because it feels to me like generally in this universe, what you're doing is additive, but that this one is really a choice, and so having a different prefix other than add makes sense. Of like you shouldn't have two uses, or at least two of these uses. I mean, I could be entirely wrong. Maybe it doesn't make sense, but it's and then especially looking at add Windows service and add hosted service, like those the use being different makes it feel like these are different kinds of things. Don't look at the similarity of names too much.
Yeah, this is an interesting one about like replacing versus adding services. With the way our DI abstraction works, there's really not a way for the person like that's adding the services to communicate intent. It's very much documented that if you add a service and it's resolved as a single service instead of using IEnumerable, that basically the last service wins. It's not an error or anything. So I'm actually not aware of any other iService collection extension methods that have a use prefix. And there are other services that like replace other services. An example of that would be like Kestrel's add socket transport, I think it's called. There are others. Kestrel doesn't like use both a socket and like libbv together.
Yeah, I'm
anyway.
running a quick. I'm also running a quick regex over ASP.NET Core sources, and everything looks like it begins with add, not use.
Can you hear me?
Yes.
Yep.
Yeah.
So these methods don't do anything unless you're actually in a systemd process or a Windows service process.
Correct.
So if you did both and you weren't in either, neither one of them did anything. If you called both and you were in one of the two, that one would light up.
Yeah, I think the question Jeremy asked is, what if I call use Windows service and add Windows service on like an iHost builder? And like
Well,
maybe it double adds the logger. I'd have to check.
no, I mean, the one I was
Wait,
going for was if you called add systemd and then add Windows service.
Oh, okay.
right, and you can only be in one of those processes at a time. If you couldn't be in a systemd process and a Windows service process.
Very good point. Yeah.
Fair enough.
I mean, but what are
No,
your
no, that-
semantics? Are your semantics then basically if you say add systemd and you're not in systemd, it's effectively a no-op?
Correct.
Yes, and that's the same with the existing use systemd iHost builder extension method. So
I
like,
see.
that kind of behavior isn't new.
It does that so you can just F5 your project and your app just runs. And then you're like, oh, now publish it to my systemd service. And then it just runs in a systemd process.
So a weird.
Logically, there's really no difference between you adding both systemd and Windows service and just one of them happens to be active versus you detect that you're not in systemd and your add call does nothing. So it's basically, from a user standpoint, it's I added both and depending on which process I'm in, like the right one will work, right?
Right. Or neither. Or if you're in neither, then it doesn't neither one.
Yeah, I
of them.
mean, but that seems easy to explain, right? Because the only thing you added were for systemd and Windows, and you're not running in either of them, so nothing happens.
Right. I don't know how that changes with the naming. If you're calling add something and it didn't do anything, if that's okay, but
I think you
mean-
make a really good point, and I think that's why add is kind of okay, because it's like you're adding these kind of optional behaviors. You're adding both behaviors. Like if I'm in this environment, then do this.
Yeah. I think to
Yeah, I
Jeremy's
think
point,
from that
though, if you
perspective,
have a... Sorry, go ahead, Steven.
I was gonna say, I think from that perspective, it's better than use because use basically says, "I want you to do X," and it says, "Well, no, I can't do X." Where add is like, "Sure, put it in the basket, and if I can use it, I'll use it."
Yep. I mean, I will say that the semantics of last one wins and add are a bit odd, though. It just happens to work out here.
that's how
And as
everything
far
works
as-
in DI.
Yeah.
Everything in DI works that way.
And
Yeah, I
going
remember,
back to how DI works, answering the question I thought Jeremy asked, we use triad enumerable for the loggers, so it wouldn't double add the loggers either if you were to like call use Windows service on a host and add Windows service on a service collection or something. For
I
that
see.
kind of weird use case.
I mean,
I mean,
from
we
that
got-
perspective, you squint. This is basically a set, and
Yeah.
sets can have last wins, first win semantics. It's just there's only one, so you can call add on a hash set, and it may not actually add anything because there may already be one there. That's detectable because you can actually the comparer could equate two things that are discernible. This is just a different policy for which one wins.
Right. Yeah, that's kind of I think what you're describing is how like triad enumerable works. It's like it will add an iLogger provider if the event logger provider isn't there yet. But if there's already like a console logger provider, it'll still add the event logger provider kind of thing. It's just like doing set lookups.
Yeah. I mean, not being familiar with the technology, my assumption was if you called use systemd and you weren't in systemd, something bad was going to happen. But if it's you called use systemd and you weren't in systemd, then it's the same as if you didn't call it. Then the two adds make sense. I was just looking at it as if this is really mutually exclusive, then using a verb other than add might help convey that. But if they're not, then I don't care. Looking at your example, I kind of want to ask if we want to add hosting on these, just so it looks different than hosted service. But then you have Windows Service hosting and hosted service, and I don't think that helps. So I'm fine with the rename. Anybody else?
All right.
Dissent in particular?
No, it makes sense. I mean, regardless of what we think of the naming convention, like the fact that it is consistent with the rest of ASP.NET is, I think, justification enough.
And thanks for jumping in and answering the real question, Eric.
All right. That one actually was fast. Who knew? All right. A new date-only converter and time-only converter class for component model 68743.
Yeah, this is so in system component model we have the type converter, which is can convert from like string to any primitive types that we have today. And in .NET 6 we have added the date only and time only types, but we don't have a type converter for those. So this is reported many times. I mean, since we shipped .NET 6, I mean, people asking for it. And it's not only about this type converter, but we have another libraries that it's using the type converter. So Microsoft's extensions configuration, for example, is using type converters in general. So if somebody want to add like a configuration for date only or time only there, it will not work because there is no type converter for it. So the proposal here is just like adding this type converters for these two types. The API proposal is exactly almost, or yeah, I mean typical as what we have like with date time converter. It's same idea, same interfaces.
Can you just remind me, because it's been a long time since I've actually used type converters, these are primarily for using configuration and data binding scenarios, like UI data binding? Is that still the case?
It's used in these scenarios, yeah, but some other people also using it directly. I mean, some people can use the type converter directly, I mean, to convert from string to something.
Yeah, I believe
think
JSON.NET also uses it.
And yeah, XML is using it, I believe, yeah, and yeah, some other libraries, I mean.
Maui uses it extensively.
Yeah, at some point we considered legacy, but I think we had to bring it back for various reasons. So, I mean, there's two public APIs, but I assume that also means you have some static registration as well.
There's built-in type converters that are built into the system. So like one for int, one for date time, etc. These would just be built-in ones as well.
Yeah, I guess my question is more like type converter is outside of Qualib, right? It sits on top, right?
It does.
And so the registration is not coming from the type, it comes from whatever the higher level is that has a list of built-in types, and we just add to that list, right?
Right.
Yes.
Like type descriptor, right, has, let's say 20, 25 built-in types. These would just be two more that get registered inside of it. So when you call, I think below it says type descriptor.getConverter or something. When you call that, it'll look it up in this list.
Okay.
That's right.
And component models at a high enough level that it can see these types.
Yes.
It's such a
Yeah.
correlate.
Yeah, the types
Yeah.
are Qualib, so.
Date only and time only are in core lib, and these two converters will live in the same assembly as type descriptor.
I mean, it looks to me exactly like what date time converter looks like, but with a different name. So.
Right.
And the only things it can convert to and from are strings. Is that true?
Yes, mainly strings, yes.
I think I remember seeing discussion of this, but I don't remember seeing the answer. Are there other new types that we've added that would demand primitives? Like, did we add a converter for half or for int 128 or any of those?
Yeah, I had some emails read with most of the people, and Tanner is the primitives that Tanner added for the numerics in general. Yeah, probably he will bring this, I mean, to add type converter for those types. So I would expect at some point, I mean, like we'll get proposal for such types to add to type converters.
Yeah, I mean, I'd be curious what the scenarios are. I have a hard time believing that people data bind half, but
Can it data bind to float?
Yeah, but I mean, float or double are actually things you can do anything with, right? Half is designed to not be. You can't anything do really with it, right? It's just an interrupt type that
No,
stashes
half you
data.
can with generic math, half is a full-fledged type and has all the support that float and double do, except for language support. So
You have to write generic code to add it to half.
no, you can just do half plus half now.
I see. So we do have operators now. Okay.
Yeah, we have the full operator support, just not the language support for literals. But if I remember right, when Tarek messaged, I indicated that adding converters for new types like int128 might be good, but it might be even better to just have a more generic iNumber converter, basically, that that supports converting any of the number types. That way we don't have to keep on, specializing in the future. That would end up covering not just half int128, uint128 and the new types, but any future types as well, or user-defined types. Because, a binary integer is just a 2's complement set of bits. There's no reason why you can't get the bits using the API surface and then do the right conversion with it.
Yeah, this is a good idea to have a common converter that can handle multiple types. Yeah, I support that.
I mean, I assume it would be built on like iParsable, formatable, right? From the iNumber.
That would be maybe a generic string converter, but you would have a binary integer converter, which takes a t where t is binary integer, and then it uses write little endian to get the underlying bits, which are well-defined 2's complement representation.
So on the screen, it's going from a string to this thing. So
Yeah.
I want to take a string and turn it into.
Oh yeah, if it's just a string, then that could just be iformatable and iparsable, or iparsable in general.
It does look like the type converters understand more than string. They just string is the one that may be the most commonly used.
Yeah, mostly is a string, which is the mainstream scenarios. I mean, using strings.
I mean, type converter is basically the full matrix, right? Anything to anything kind of thing. It probably doesn't make a lot of sense for things like date only or time only, because you really can't. I mean, presumably you could do a date only from a date time, for example, but yeah, I think for most of our numeric types, it would come down to, well, what happens if you have a double? Can you convert that to a half, for example, with, truncation, for example?
Yeah, well, and the generic math APIs expose that. You've got create checked, create truncating, and create saturating. And so you can convert from a half to a double, or from any type that supports converting to a double. And define whether you want that to saturate, truncate, or throw on overflow. Although for double there is no overflow, it's just infinity.
Do we
date
want
only?
not to get too far from the not to get too far from the topic at hand, but doesn't this run smack dab into the issues of those create methods can only create what that type knows how to reference? So if we were talking about creating a generic iNumber converter and you were trying to convert between a number from assembly A and a number from assembly B that had nothing to do with each other, how would that work?
Right. If neither type knows about the other type, then the only way to do it is with the iNumber, with the system numerics iNumber converter, which allows the user to basically inject their own converter between the two types.
Yeah.
Aside from
This
the
feels like something
binary
where-
integers, but
This feels like something where we both should prototype it to know that it's actually feasible and to prove out the generic math interfaces.
Yeah.
Regardless of that, is there anything that would stop us from approving an int128 converter and a half converter as part of this same API proposal? Because those converters, we could approve the API shape here now. We know what it would look like. It would subclass base number converter.
Yeah, I mean, it's just if you look at all the existing ones, they all have the same pattern, right? Basically would boil down to just the name of the type, right?
Yeah.
Which I think is just type name followed by converter, right? So it wouldn't be.
Yeah, I'm not. So again, it's been a long time since I've used the type converter stuff. But last I remember, to your point earlier, Emo and Eric, there's basically a lookup mechanism, like get me the converter for type
Yep.
X. Do these even need to be public for that use case?
They are traditionally.
Just because, or like, do people actually? Is the common use case to actually refer to them directly?
So
One thing
when
you
I
can-
was, oh, sorry, go ahead.
One way you can use them is you put a type converter attribute on something, and then point to that type.
Yeah,
I see.
when I worked on the model binding infrastructure for MVC, like we explicitly looked for things like type converter attribute, and we referenced the publicly available type converter types because we wanted to do the same thing that Convert was doing under the covers, but we had a little bit extra logic we tacked on top of it. So having the types public is useful for extensibility mechanisms.
Right. So for programmatic access, you probably wouldn't use these, but for attribution-based use, you would.
Right.
Or if you wanted to wrap one for some reason, you knew you wanted to wrap a date only converter, and did some more stuff, and then called the date only converter.
Sure, but even in that case, you could always just do get me the converter for date only. It's just a factory versus a constructor.
Yeah.
Yeah.
I mean, I picked decimal just as a arbitrary one to click on, and it does look like WPF and XAML, which I guess is also WPF, do have places that they are directly instantiating the converters, but it may be that they're just unifying it with their attribute lookups.
That's fine. I just wanted to make sure we were making them public for good reason.
Yep.
It sounds
Yeah,
like we are.
So
think we
interesting
never-
thing about MVC. Oh, sorry.
So no, go ahead. Like I mean, we never liked type converters, so it's more or less a legacy design in general. So I
Right.
also don't think we
Like
quite
MVC
understand
still
it.
uses it.
Yeah.
Maui, the latest UI stack we have uses it.
Oh, really?
It is-
Yeah,
it is
MVC still
convenient.
uses it.
Yeah.
Minimal doesn't. MVC supports like date only and time only already because we just added behavior to try parse. At least in .NET 7. But I think we would prefer the type converter for backwards compatibility once it's added. Might actually slow things down slightly, but we'll see.
Yeah.
Yeah, in full framework MVC, the pattern that we had was we looked for a static try parse method. Failing that, we looked for a type converter. Failing that, we looked for a few other things. Like we had this whole opinionated thing we looked for.
So then how about we approve what we have here? I mean, I'm okay with approving it for half and what was the 128 type again?
Int 128.
Yeah,
Yeah.
int and uint 128.
Because I mean, it is just the same naming convention, right? And then the overrides I generally don't care for anyway because they're already on the base. So
That's
it
why I
really is just
deleted
for
them.
jamming. Yeah.
The reference assembly does have to contain the overrides.
Sure, but
Yeah,
our minutes from this meeting don't.
sure, fair enough. Because Jeremy, you remember the bugs that that cropped up once we started introducing overrides in intermediate classes.
Yeah, the C# compiler does override wrong.
Yeah.
Jared may
Ish.
disagree, but he's wrong.
I don't think it does. It's just the design that they now have.
Yeah. The compiler should write the call to the base class, not to the base class that defined the override.
Yeah.
The runtime should figure out where that actually goes. Okay. That said. So, yeah. So, half and 128 and uint 128, are those the ones we need?
That's what I heard.
I think so. Yeah.
Do we need inint? It doesn't look like there's a converter for int pitter at all.
Yeah, if there's none for int putter or uint pointer, then we should probably add them for inint and inuint.
I mean, we could, but we also, this stuff has been around for 20 years and we haven't needed those for 20 years. So do we need them now?
Yeah, what people do in practice is bind to long and then cast from long to int pointer.
Yeah, I
Right,
mean,
but there's the whole like in .NET 7, int pointer and int are true aliases of each other. So for consistency reasons, it makes sense to try and make sure that it continues being first class and not second class.
Sure, but this is legacy. I mean, effectively legacy, even though we're using it in various places. But like all this stuff was built up at the same time that int pointer and uint pointer were around. If they hadn't been needed, just because we're giving it a type alias in the language doesn't mean it's going to become much more popular in the stacks that we're using this stuff. Because if it was, they would have just used the int pointer and uint
I
pointer.
mean, I guess it's true of why is a UI framework using inint, because it can't, like, it's going to have trouble describing what that means. We can say that
I would hold off on that until we have an actual use case for it.
For inint and infloat, I think we maybe want to wait.
Yeah, there's probably more as an interrupt type, so unless there's a scenario for it, I'm okay saying no for now.
Then I think the only thing that might be a future consideration would be a general parsing converter that just takes T where T is iparsable, but that can be future.
Yeah,
I
would
be curious. I think that would be a good idea. Yeah.
What would I mean? I think the question is like, can you have a type converter that is effectively for any type that implements an interface, right?
Well,
but probably not, right?
All of the implementations here are basically just checking the string and then calling parse. And they're doing minimal checking of if the string looks like it contains an X, then call the hex parser, otherwise call this other parser. So
right. Yeah, I mean more like, I mean the code is trivial, right? It's more about how the how the registration, I guess, works, right? Because I think you can't quite ask for the interface, right? It's just the whole infrastructure is basically register for a type. You ask for a very specific type, and then you have to return something, right? So you would have to do some weird gymnastics to say, I can do anything that implements I formatable or I parsable.
Yeah.
Which is, I think, partially because, I mean, I think this was all pre-generic, right? So a lot of the code is just fairly boilerplate to begin with.
Yeah, I mean, it has a weird, can convert, and certainly it could be implemented as, I don't know, ask it, does it support iparsable? Yes. But then that's weird because you don't know what kind of string you're getting. So.
Right, and for dynamic lookup, you also wouldn't even know which instance of the converter to return.
Right. Yeah, I mean, if we think that, a more genericized thing can replace half int 128 and uint 128, like, if nobody implements them, we can, we're approving the shape. We don't have to. We're not saying somebody has to actually go write it. We can delete it later if we haven't added it. Yes. We can replace these three with something else if we think that's better before we ship. How about that?
We have enough trouble approving APIs people actually want to implement, so you should just keep going.
All right. Anything else on this point?
Oh, looks good. I mean, as good as type converter.
I guess I'll write down.
We still hate it, but we approved it. Oh no. Oh, we have float as well.
Yeah. Did I hit submit on that? Yes. All right. System reflection function pointer info 690273.
That seems reasonable.
Yeah, I can go over this. I should have probably reworded this main API proposal name. The original proposal was to create a new type called function pointer info. Now it's not. So
I see.
Fair enough. Is the top post correct though? Like,
yeah.
Okay.
Okay. Do you want me to go over this?
Yeah, go for it.
Please.
Okay. So today, if you call, if you have a method parameter that uses a function pointer and you try to get the type from it using reflection, it returns int pointer, int ptr, and that's also a type that you can use elsewhere. So people don't know that this particular method parameter is an int pointer or is it a function pointer, that sort of thing. Anyway, it's been broken now since 5.0, since function pointers were added, and this is introducing a breaking change. To change that, instead of returning int pointer, we're going to return system.type along with some methods here to determine if it's a function pointer, and that's what the is function pointer is. Function pointers, have been in the CLR forever, and just like all of the other value types versus reference types and arrays and that sort of thing. So it does make sense, I think, to put it on type. There's some discussion down below that originally I had a different class to wrap these other methods here on these other 3 methods, but I think this is the right call. So you can ask if something's a function pointer, and if it is, then these other 3 methods can be called. And let's skip the first one. Function pointer return parameter and get function pointer parameters is pretty explanatory. It returns a little helper class that returns the information that we know about, parameter type and position, that sort of thing. And then this top one here, I'll come back to that in a little bit. Function pointer calling conventions, because it's maybe the only non-trivial thing on here. Well, can you scroll down just a little bit? Okay, just so we see all of the API. Okay. Yeah, so function pointer parameter then is a new type that was added to return the small set of information that we know about function pointers. There was some debate and discussion around using the existing parameter info as is, and then throwing and returning default values for cases that we don't know, or possibly subclassing the existing parameter info and using that or I should say adding a base class to parameter info, not really subclassing it, but and then use that base class, just say parameter info base, and go with that. And after some discussion, no one really liked the base class idea. Has some wrinkles in it. So the options, I think, were either to do what I did here, function pointer parameter, new type, or use parameter info. So we just decided to go with the new type.
Can we put custom attributes on function pointer parameters?
No.
So the only thing that are valid.
You can add mod ops and IL, but
right.
you can't
put custom attributes.
So these get optional custom modifiers and get required custom modifiers, yeah, are just returning the mod ops and rec ops, I guess, from what we have in IL metadata.
How do we expose them normally? Are they on type?
Yep, no, the same way. You mean the optional, the modifiers?
Yeah.
Yep, parameter info has these exact same methods. So in fact, it has parameter type position as well.
Oh yeah, no, I see it. For some reason, get optional custom modifiers. Yeah.
Basically, everything here is the same name and signature as what's on parameter info, except a very small subset of that.
I thought types could also have mod recs and mod ops. Am I wrong?
They can, but those change the Well, it's not that the type gets the mod rec. It's that the type declaration when you're using it inline in a method gets the mod rec or the mod opt.
I'm just like looking for get optional custom modifiers. We only have it on field info, parameter info, and property info.
Yeah, I think that's probably wrong from an IL standpoint, but I think that's what we do.
Fair enough.
I mean, that makes sense to me. I mean, if a function parameter is basically a function pointer parameter is fundamentally different from a normal parameter, I think having the base type would be worse. If half the things don't do anything or do something surprising, it seems easier to just say they're special and we expose what makes sense. I think that like I don't think people would write generic, I mean, wrong version, but like a general code that would process either parameters or function pointer parameters anyway. So I think if you care about function pointers, you go down a very different path probably.
Right. That was the thinking and the discussions that we had as well.
And just to understand the break and change, you're saying right now when you ask for the type of a function pointer, we return not an instance of type that points to system in PTR. We literally return in PTR as the type.
Yes, and mono does something different. Mono has a dummy type that's exposed. I mean, it's an internal type, but yeah. That's just the way it ended up. I think that was maybe the least friction back then. I don't exactly know the total history of that. But yeah, it's basically a big gap right now in reflection that you can't. First of all, you can't even you don't even know if something's a function pointer, number one, or some other in pointer. And then number two, you can't look at any of the parameters.
Right. So that to me is a kind of like one of those acceptable breaking changes, right? Because it's, we basically make something work that doesn't really work today.
Yeah, I think so. I mean, if we didn't want to make it a breaking change, what we would have to do, add some helper methods to in pointer and tie extra state on there, and that's not going to work. In pointer has to serialize as a,
yeah,
pointer.
is function pointer would be a weird API on NPDR.
Right. So I don't think it's feasible to have another, a way to do this without making it a breaking change. And I think the community and everyone that wants this feature is okay with the breaking change. I don't think anybody has said, hold on.
Can you invoke a function, a method today that takes a function pointer by just passing in an EPDR as the value? Does that work?
Yeah. What do you mean by that? You can. I mean,
so we have a
reflection invoke or using function pointer direct call.
No, I meant like let's say there is a normal C# method and one of the parameters of the method is a function pointer. Can a reflection invoke that method passing in an inptr as the parameter value for that function pointer? Does that work?
I think you have to create the special pointer, system reflection pointer type, which tracks the underlying value as an inptr plus the actual type descriptor of the type. That's how it works for regular pointers, at least.
So presumably with that change, that path would still work the same. So reflection invoke would still work the same, I suppose.
You can get from the function pointer in code. I mean, if you have the function pointer, you can cast it to void star. You can also then convert it to in pointer if you want, and pass it around however you want. And then if you need to call it, you cast it back to void star, and then cast that to the actual function definition.
So I didn't mean invoking the function pointer. I meant more like if there is a C# method that accepts a function pointer, can I call that method passing in a function pointer?
Yeah. So this does not change that.
Right.
We did discuss having a combination like the system.pointer class and having system.function pointer. that would do something similar to system.pointer. And we can still do that, but and that contains both the type and the value. So that's useful. Although system.pointer doesn't let you get the type out, which is slightly confusing. But in either case, we're not changing the runtime behavior
Right.
of marshalling, I guess.
Yeah, that seems reasonable.
Strictly, well, we are changing the introspection side of reflection, right? So the breaking chain is going to be very specific to people that are using reflection to look at types. And invoke, we don't. There's no proposal here also to add invoke methods. We can do that in the future. Like delegate has an invoke, and method info has a way to invoke it, that sort of thing. Dynamic method. Anyway, we can add that later, and the idea is that would be somewhere else, not on type, of course, and not on function pointer parameter. It would be a new type to help you with that.
Yeah, so function pointers can only be used as parameters and return values, and presumably also as fields? Or can they be anywhere where a type is valid?
They're
Anywhere
not.
a type is valid.
Go ahead.
Anywhere a type is valid. They work as fields, method, properties.
Presumably not as a base type.
It is a type. It's one of the handful of core types the CLR was originally created with. So it is. And C++ CLI has been using this for a long time.
Yeah, and in fact, some of our internal types have fields that are function pointers. So it's stuff that we have used in the past.
Makes sense.
Okay,
so in that
I
sense,
can talk...
invoke would be reasonable, but yeah, we can do that later.
So this then exposes this parameter class, minimum information on it, and then adding the 3 methods to type. The first method, though, I'll come back to the only thing that's slightly tricky here, is that it's basically the issue is that the metadata that we have today uses a call kind enum that we do not expose here because it hasn't scaled very well. And if you have any kind of native code, it's kind of not very helpful because you have to look at the mod ops to figure out the different calling conventions. So instead of exposing call kind and leading people down the wrong path, maybe, because they might assume too much from that we're going to have a little helper here that basically just wraps the return. It basically calls into function pointer parameter for the return value, because that's where the mod ops are stored for the arguments. And it only returns the types, the mod op types that start with call conv. It might have other mod ops on it, but we don't return. We filter on those so people can just look quickly, get easy access to those, so they don't have to do that filtering. And know that they have to look at the return parameter to get those.
So yeah, I think we need to also expose the call kind, because the way call kind works is that if it's one of the built-in calling conventions that has existed since .NET 1.0, so cdecl, this call, standard call, etc., then it returns that call kind, and there are no call conv mod ops. If there are multiple calling conventions, or if suppress GC transition, which is another calling convention, is used, or call conv member function, or any of the new calling conventions, then it's the special calling convention bit plus the calling conventions that are exposed, and so both bits of information are important.
So I'll reply to that, and let me know if this addresses that. Is that I try to explain this in the comments. It's not very intuitive, though. Is that what we want to do is just have one place to go to figure out the calling conventions. So if the call kind is something like standard call, and there's no mod op for it, we will manufacture, synthesize that custom modifier so everything's consistent. Because there is more than one way to define these mod ops. I mean, with call kind, and using call kind, not using call kind, using mod ops, not using mod ops, and so the idea is that we just have one view of the world, and we don't need to call kind because we will synthesize the correct modifiers if they're not there.
If I remember correctly, and you might need to check with Jeremy Krinsky, but
I'm here if we have questions.
Yeah, I believe these. I thought we decided that if you encountered a function pointer that had mod opt callcon cdecl, and that's all it had, that it wasn't going to be recognized as regular cdecl, and so therefore they were different types, and they are indeed different types from the type system point of view, and so they are incompatible, and just mod opt callcon cdecl is invalid and unsupported by the runtime. You're expected and required to use the underlying bit that exists for it.
That is untrue. We use I think it looks for typing of the function. The runtime recognizes if you just specify cdecl as if you do the unmanaged bit and then say callcon cdecl, the runtime will recognize that for the invocation.
Okay, but
we do not
C#
require
will
it to be
not.
one or the other. I
C#
think
will
C#
not, however.
will. I think C# will.
It can't because they're different types. They are fundamentally different types and not assignable to each other.
Okay. I'm not sure. I know what C# admits is. Yeah, and maybe Aaron can speak up here.
Logically.
Can I be heard? Am I heard?
Yeah.
Okay, so if I recall, and this is we could ask Fred for sure, but I believe that the attribute always, if we see the attribute, that is what it is, regardless of that call kind value. And we can see that I literally just fixed a bug where the call kind is win API, but the attribute is callcom cdecl, and it is a cdecl. This is in system private correlate. And so that actually does happen, and the attribute always wins. And I'm pretty sure that is what we agreed with when Fred was implementing the feature. We went through this of what is reality, and the reality is the cdecl, the attribute.
So what happens if the user specifies cdecl and the mod opt?
The mod op always wins.
And then it'll switch both to being emitted as mod ops. I'm checking the C# on C# lang, the spec for calling conventions, and it says for the original ones, you always specify them the same way. And then for compat with C++ CLI, it emits the built-in ones as the legacy style encoding with call kind. But from the representation of in the C# language and from reflection, you're not going to have a function pointer that has the unmanaged bit for call kind and then has just the single mod op for cdecl unless you're writing an IL.
Right, and then does C# then define some identity conversion between unmanaged bit plus cdecl versus cdecl bit? Because at the runtime level, those are incompatible, or at least at the type system level, those are non-compatible signatures. Because modop changes the signature to be a different overload and therefore incompatible.
Logically, there are always only the mod ops, call conf mod ops, and the only trick here is kind of the encoding. When you have mod op that is of a specific shape, it's encoded differently. It's not encoded as a mod op in the metadata. It's encoded as the call kind bit, right? So it's kind of similar to the way custom attributes work, kind of the magic ones like DL import. You see, in C# you see DL import, but in metadata you don't actually see DL import attribute. You see some magic bits in some metadata table, right? So I think that this call kind, the call how the CDECL call conf is treated or unified. Basically, it's I think there might be even a language in the C# spec that says that basically encoding the plain CDECL as unmanaged pass CDECL call CDECL call conf is invalid. Basically, it's like non-defined behavior. Does it
Right.
make sense?
And so my concern here is that if we decide to normalize the reflection stack and it doesn't match what's representable in IL, that means that you can no longer differentiate between some user language or whatever that has gone and exposed both CDECL bit and unmanaged bit plus modopt callcon CDECL, because both of those are valid to exist side by side in IL.
No, the later one is invalid encoding. It's like non-defined behavior. The only correct way to encode.
Aaron and Jeremy just said that the runtime recognizes those and treats them the same, but at the IL, C# treats it as invalid. And so, but in IL, they're fully definable and distinct and separate. And so at the IL level, and therefore the reflection level, you can differentiate between those two.
No, you don't. Like, it's invalid encoding, right? You don't have to, at the reflection level, you don't need to be able to represent every invalid encoding in metadata. We don't represent invalid metadata in the reflection, right?
Right, but Aaron and Jeremy were saying that it's not invalid metadata. The runtime
We're not saying
supports
that.
it.
We're saying it works. Whether the encoding is valid or not is a different situation. The cost of blocking that specific type of encoding is not worth the cost. The fact that it works is it's more expensive to make it not work, but we're still saying it's invalid.
Okay, so that also seems problematic, because that means that the runtime will work and not explode if I emit an IL assembly that contains both of these side by side, and one of the methods suddenly becomes effectively inaccessible and undefined behavior, and the user may think that something's accessible when it's not.
Right, but if the spec says it's invalid, then maybe Mono doesn't load it. Like, once you're doing things that a spec says is invalid, and it doesn't crash, you're in the good luck realm.
And there's always metadata reader as well if you really want to see what's there, of course.
Well, it's kind of a consideration for if you're using reflection emit or any kind of other functionality to go and write IL, or even trying to, for example, walk the methods exposed. Then what happens when you encounter this, and how can you differentiate between the two if necessary? And it feels like if it's invalid, then something should be blocking it.
Well,
right, but I don't think that's a consideration that the reflection API needs to make, though.
Yeah, I mean, if you want to argue that the reflection level should say this was declared as invalid IL in the spec and reflection is already expensive enough, it can do the throw, sure.
I mean, that seems like it's complicating stuff, though, for something where we can answer the 99.9% use case just fine. Like, I wrote in chat, like, the reflection API doesn't have to give a 100% accurate view of the world. Like, the thing that we're considering right now, right, is that the reflection API lied about function pointers for 20 years. And for the most part, no one cared. It's just once people start caring, now we say, okay, maybe we should make life a little better. So we make life better for the scenarios that we care about. But if you want a fully accurate view of the world, as was mentioned earlier, metadata reader is right there.
Right. My concern was mostly if the user encounters IL and they're reflecting over it, then does something explode or does things get into weird edge case behavior? And if we're saying it's weird edge case behavior, that's fine. But when my initial understanding had been that it's supposed to be invalid and they're supposed to be different from each other, and so therefore we should expose it correctly as the user would actually have to encode it, which is there's an unmanaged bit and then you check the calling convention separately.
There should be one more thing that we consider here is manage function pointers. I mentioned this in chat, and I was wondering, how is the calling convention represented for managed function pointers so that you can differentiate between an unmanaged function pointer that just has the unmanaged bit and no calling convention mod ops, and the managed function pointer that obviously doesn't have any mod ops because it's a managed function pointer.
So do you need to be able to differentiate that for the scenarios that people might want to know about? Because remember, there's no invocation API here, right? It's just, let's inspect the parameters, let's inspect the mod ops on the parameters, stuff like that. Like, it might be, I guess I'm having trouble figuring out, like, for the APIs that we're exposing here, why would someone also need to know whether it's managed or unmanaged?
My thought was,
like, what would they do with that information?
It falls into the calling convention space of we're exposing the calling conventions of the function pointer. We should be able to know whether or not it's managed or unmanaged, primarily because if you can detect it's unmanaged, if you're trying to figure out the exact calling convention, if you know it's unmanaged with no calling convention mod ops.
And if you're trying to do type of t dot get methods or get method, and then you're passing in the parameters, you need to be able to differentiate between the overload that takes a managed function pointer and the overload that takes an unmanaged function pointer of a specific set of mod ops.
I don't know if we really want to go all that deep right here.
Well, I mean, if you want to support reflection for function pointers, that would presumably include enumerating methods and being able to, like, it doesn't seem right to go halfway with function pointer support, like expose the type, but then you can't actually use the type for picking the, for picking the right overload out of get methods or anything like that. That just seems like you're going halfway and exposing functionality that's not really useful yet.
But you either have, I mean, is this that you want to look at two different overloads and be able to figure out why the two types are different between them, aside from the fact that they have different, type objects?
Well, like with reflection, one of the things you can do is you can get the methods for a type, and you can get an exact method for the type based on the parameter types to that method, so you can pick an exact overload.
Right. So you already now have the type of that is the managed or unmanaged function pointer. You don't need to know which one it was. You have that type of.
No, you have to declare your own type of to create it, right?
Right. The get method takes types as a parameter.
Right. Given that if you're calling get method and you're looking for an exact overload, you already have a type object. So you don't need to ask that type object if it's a managed or unmanaged pointer.
Jeremy, you're breaking up. We're having trouble hearing you.
You sound like a Cylon.
So you're saying that a user will always have to manually declare type of and then type out delegate star managed blah, even if they're in a language that doesn't support function pointers, like F# or VB, then they have no way to do anything with those methods via reflection.
No, I'm trying to understand your example. You're saying you're calling get method. That means you already have the type object. So you've solved your problem.
You have basically the type that exposes the methods.
Yeah. So okay. The idea
you don't have the type of the parameters necessarily.
So the idea is whether or not it's managed function pointer would be stored internally in the object, but would not be exposed to the user. So if you did type of and did delegate star versus delegate star unmanaged, they would still be different objects, but there just wouldn't be any properties that show that they're different, other than checking that equals fails.
Right, but if you have some target type and you're calling get method to find a specific method that has a name and a particular overload, overload signature, you've already solved the problem of how you got the type object to do that. And if you're looking at all the types in the universe and you're trying to find the one, like, you can either walk through get members and then say, great, I have these two different T's, why are they different? And maybe that's a question, but it sounds like there's a calling convention, so maybe we just make this one represent a synthetic I'm managed or unmanaged if that's a call conf type it can represent. Like, maybe from here you can't figure it out, but great, you had a higher level thing, ask that. This is a different method. It's allowed to do things other than just filter, get optional custom modifiers. It can make up answers.
Yeah, I'm somewhat lost in like what is the concern? The concern is we need to know whether it was a managed function pointer. I mean, that seems like something that should be a member on type then.
Yeah.
Right,
And there was
because
a
there's a difference between managed and unmanaged, and a managed and unmanaged function pointer, neither of them have any calling conventions. They're just they've got no mod ops. Yeah, they're the default. And so you would need something like is managed function pointer and is unmanaged function pointer. One of the two to differentiate between the two concepts.
I just added that in the chat. We have an is function pointer. Let's get rid of that and differentiate the managed or unmanaged. And that handles all of our things. So then we have the is managed, is unmanaged, and then calling convention.
So basically you would have is managed function pointer and is unmanaged function pointer?
Right. And as Tanner said, you can have a managed function pointer with some of these mod ops.
They don't do anything right now. They can just be there.
So a function pointer is either managed or unmanaged? There's no
Correct.
third kind? So
There
it seems like,
well,
why would we not just have public virtual bool is function pointer and then another one that is basically saying, is unmanaged? That is either true or false?
That's fine too. I guess if we already have a function pointer, I think I look at this from if you have a managed function pointer, you can call it anywhere in managed code. Just do that.
I see.
Alternatively, we could say that as far as I'm aware, managed function pointers are never valid with any mod ops, not GC suppressed transition or anything else. So we could say function pointer calling conventions returns a nullable type array, where null means it's managed and empty means it's unmanaged but with no mod ops. And then
I guess I'm hesitant to consider that, Tanner. I think that's reasonable, but I think that we've already proven that having the modifier calling convention idea has legs, and that's my concern. I think right now that works, but I'm very hesitant to say we're going to have modifier calling conventions that I think are applicable to both managed and unmanaged function pointers.
you're thinking maybe for example that there's a default managed convention and vector call managed convention if we wanted that.
Yeah. That is the exact example I was about to give.
Yeah.
There's actually today there are already multiple managed calling conventions. They are not just usable from C#. You can have like instance managed calling convention and static managed calling convention. The only one that's supported in C# today is the static managed calling convention.
And we should have a member function mechanism for that.
Should there maybe be a function pointer type that inherits from type that exposes the function pointer specific functionality, since it's kind of like a method and therefore might include other things like is explicit this or things in the future? Like it's basically type plus method info in a way, but without a.
I mean, that one seems weird because the current universe is, I mean, type is abstract and you never see one. You see an RT type. And so making a new semantic extension of type feels like it would complicate that universe.
Yeah, and
Yeah,
this was heavily discussed earlier. If you read some of the comments down below, that and then basically having another type, I guess, in general. But I mean,
Yeah.
I think that we should figure out this is part first,
Yeah,
is managed before we change topics.
Yeah.
I guess my concern is that like function pointer has enough concepts that are unique to it that it. I don't know if it's going to be weird or not to have is managed function pointer, is unmanaged function pointer, and in the future potentially, you know, how is this call going? How is explicit this going to be represented for a managed function pointer if we have it? Are we saying that that's just going to be this call or member function?
I think what I would probably prefer is not a new type derived from type. I think if we have enough meat that we want to factor out, I'd rather have a method that gives you, similar to function pointer, just some data structure that returns that contains all of that information. I would not try to solve this problem by polymorphism.
Yeah, sort of.
Yeah, so that, as Steve mentioned, like there was ample discussion in the issue itself about why that was considered and ultimately rejected.
Sort of that type thing, Emo.
Yeah, something like that. I mean, I'm not sure I would call it pointer type info, but yes.
I don't imagine anytime soon anyway that there's going to be more than this additional bool that we're talking about. So I think we can, you know, I don't think we want to over design it here.
Yeah, I mean, I kind of agree with that because, I mean, if you look at type in general, like it represents everything today, right? A generic type, an array type, you know, a pointer, like everything, right? So I think it seems logical that that also represents function pointers. And maybe there's some members on that that only are applicable if you're a function pointer, which is also very consistent with how reflection works. So are we okay with that API, or should, you know, is there more discussion that needs to be had? Because it sounds like there's still some discussion on the semantics.
Well, that first property shouldn't return an array. Like, it should be a method that returns an array.
Yeah, I mean, if we're done with the concept, then I have several points. But
yeah,
which would be, I think that the first two properties should both be methods, and then the extra type of function pointer parameter, every other thing in reflection ends in info. So we should put info on the end of that, even though it doesn't extend parameter info.
I would agree with that.
How expensive is it to look up whether a type is a function pointer, either managed or unmanaged?
Is that a question for me? I don't know.
Sure, yeah. So if I want to know if a type is a function pointer, like, do I have to say is managed function pointer or is unmanaged function pointer? And is that going to potentially, you know, cause chatty calls back into the unmanaged runtime?
You know, figuring out whether something is function pointer is cheap, whether it's managed or unmanaged, it's like more expensive. It requires signature parsing. Okay? So, yeah, I kind of dislike having two methods to differentiate between those two. It doesn't feel right.
So
yeah, because I could imagine, for instance, like
that?
system text JSON's going to have to call into this, right? Like, system text JSON's going to have to change their code to say, well, we called is pointer, it returned false. Now we also have to look for these other two methods.
Oh, types to not do things with.
Well, for fields, yeah, because types can have fields of function pointers, right?
Yeah.
Like, which to me kind of means that having is pointer return false is actually the wrong behavior, because it means that if you are a net standard component, say, and you want to very quickly check to see, is this something that I can serialize? Like, you now have, like, how does that even work for existing code? Like, what do they have to check using only net standard APIs to know whether or not this is something they know how to handle.
Yeah, what is the current reflection behavior?
Return
When I
something
ask-
akin to endpointer.
I still don't know how that works, because if I'm on a method and I inspect the parameters, the parameter type is of type, right? So how do I get it back in PTR here?
It returns something akin to type of endpointer.
Oh, I see. So basically,
You have
okay,
to- Yeah.
so the type
You
that I'm
have to
getting
say
back.
point.
So what did you say, Stephen?
Oh, sorry.
Steve.
Yeah, so like what Levi said, it returns this kind of this opaque type that derives from system type. You don't really see it, and you basically have to call is pointer to figure out if it's a pointer. But I mean, typically, if you'd like to do a two-string, it's going to be ampersand, whatever the and then whatever the type is, int or whatever.
I mean, we could make is pointer return true. Then, if Jan's point is function pointer is cheaper than asking is managed function pointer or is unmanaged function pointer, we can have 3 cascading infixes of is pointer. It's a little weird, but it's not terrible.
I mean, another way to do it is to just say, is pointer returns true, and
Yeah.
then there's this method you can call like get function pointer info that basically contains everything, right? That does the signature parsing once, and then you have everything.
Well, is pointer would still return true for types that are not function pointers. So there's still is function pointer being different than is pointer, but they can both be true. It's a pointer type and it's a function pointer type.
Yes, I guess that's what I was trying to say.
I do think that will be another level of break and change, though. In particular, people that call is pointer expect element type to be none null, and I know Levi, you brought this up as well.
You could always say it's void.
Return void star instead of our void type. I mean.
Yeah, so you can say
element.
if it's a function pointer, then is pointer returns true and the elemental type is void. Like it's a little hacky, but at least it like clearly tells the caller this is a pointer to something else rather than something that has data on its own.
Yeah, that might work.
But I am concerned though that we have an enormous amount of code today that performs reflection. Again, serialization is the big one. And like if they might have logic today to say like if is byref or is pointer ignore or if is int pointer ignore, and now all of a sudden like they're going to start trying to read data that makes no sense.
Yeah, I mean, making is pointer return true, I think makes sense to me. And I mean, it might be a breaking change, but I think the real breaking change here is that APIs that deal with function pointers have basically not been used, and now they might be in use, and that will break people, right? And I think the question is now, what's our best strategy to contain the damage, right? So in that sense, I think the proposal makes sense to me.
Yeah, I did put it here for discussion purposes, because I did debate whether we want to return true or false for that. But I think that the main element stopping me was this element type, and if we can return void, I think it makes sense to change or change the semantics of his pointer to return true.
So what I heard from Jan was that checking whether something is a function pointer versus a pointer is cheap, but then getting more details of it is somewhat expensive. Is that fair?
Yes, where you have to do a lot more signature reading.
Right. So it sounds like the is function pointer is cheap enough.
Function pointer does make sense. In order to handle this, I have there's another option here. We can create another call conv managed, and that will represent the managed case. So that would basically mean we would extend our already existing semantics by adding a call conv managed under the compiler services namespace.
Yeah, and that's I think what I was suggesting is have this member return a synthetic the managed call conv, because it looked like somebody said call conv managed in chat, so I assumed it was an existing type.
Would a
Yeah,
We'd
call
have
it's
to-
okay for that API to lie.
We'd have to make sure that if we introduce that type, that the runtime also correctly handles if you type delegate star unmanaged call conv managed, and either makes it a managed calling convention or throws an exception saying this is invalid,
Right.
so that if
Would
someone
we-
actually types it out.
Why do we have to support that? Like, why can't it just be documented? Like, this is purely synthetic. Don't use it.
The runtime needs to do something, otherwise.
Does it?
But yeah, because you
It-
can use it, right? Like, I mean,
Yeah.
you want some behavior there, right?
I mean,
Yeah,
if you
we want
apply
some
it
defined
to
behavior.
I mean, ignoring it is a defined behavior.
But so we just treat it as an unmanaged call, or we treat it as a managed call?
Well, what
It would
happens
be
if you see
documented as this type is purely synthetic. It's only for reflection purposes, and you should never apply it to your own call sites.
if you were to see a call conv you didn't understand, what's the runtime do?
I believe right now, I think it ignores it because we know all of the types.
We do ignore it. The
Yeah.
point here, the meta point, I think maybe that Jeremy's getting at is if we go down this path and we see callcom managed, so that was the user's intent, it will fall back to say this is a unmanaged function pointer, platform dependent.
And then if you
Yeah.
tried to reflect on it, then you get back that it's a managed function pointer.
Fair enough.
But don't do that.
Which,
Like,
But
if you-
someone's
agree, but-
going to do it.
But
Yeah, but I
but
mean-
they like I'm not interested in having the framework defend against people doing all manner of idiocy, right? Like if someone really wants to
Interrupt-
know
yeah.
what the IL actually said, metadata reader is right there. Reflection doesn't have to be a perfect representation of the world.
But I mean, what are we trying to achieve here? Right? I mean, like, is it really so bad to have an API that tells you that? Like, why does it have to be a synthesized calling convention if that has the encoding downside? Because I mean, we can control what the API shape is, right? I mean, we can do whatever we want here. It doesn't have to be a synthesized calling convention, right? And it seems desirable to avoid that because then people can't actually write it the wrong way, right?
Yeah, I mean, like this
The-
sort of sounds like what we want, like taking the relative expense of the things is that maybe is function pointer, and that's the only thing we add on type. And like Emo
Right.
suggested, we had a second thing, get function pointer info, that returns a type that we haven't written down here yet, which moves all of these things onto it. And
Yeah.
now it's like, great, now you're asking questions. We'll add the is managed property and is unmanaged property and smells like tomatoes and whatever other things are important to know on function pointers. That we now have a
Yeah,
place to
suppose
contain that
yeah.
information.
Jan proposed a good idea in chat of having a new call kind of unmanaged type that we wouldn't have to add support for in the runtime, as correct support would intrinsically fall through. The syntax would be odd because it'd be delegate star unmanaged, but then it's not contradictory. And then the default, the empty one, would be managed, and then we wouldn't have anything particularly weird or contradictory there.
I mean, that would work.
The question would be then, does the language need to block the user from specifying that themselves, or does the runtime have well-defined behavior if it sees unmanaged, and what happens when you do unmanaged function pointer, or no, unmanaged callers only type of unmanaged?
So I just want to call something out here. From the runtime side, handling any of these however we want is really simple. So if we want to use managed, stupid simple to do. There's like one very targeted place. We've consolidated almost all of this. So I think unmanaged makes sense. Managed is also very simple to handle. Like there's very little cost from the runtime side to either block or forever ignore unmanaged, either one. So I guess let's I wouldn't try. Basically, what I'm getting at is I wouldn't put too much emphasis on what does it cost the runtime. It's very simple either direction.
Yeah, so basically what's down, what's the better API, right?
Right, exactly.
So I don't have a preference because I don't know enough about the domain, but like it seems to me that if calling conventions is kind of orthogonal to whether it's managed or unmanaged, then it seems to me having that in that array is not actually that helpful. If we think it is more useful there, then yeah, I think the proposal makes sense. But if we just do it to avoid exposing a property somewhere, then I'd rather do that. And that's also kind of why I proposed the secondary type, because I would assume that, you know, is function pointer is a cheap check, and then anything else involves signature parsing. So when you have a make it a method and return an object, well, that's when you pay the price once to go over everything, and then the user has all the information they could possibly want, and then everything there is cheap.
I do think adding the extra additional property is probably the simplest. If we start adding new calling conventions, even though they're only used by reflection, if I recall correctly, Rosalind actually has a naming convention where they just search for callconv, and then allows that. So it could kind of mess things up and cause some, issues elsewhere. If we put the callconv in the reflection namespace, if we added a new one, that would probably avoid those issues.
I'm just doodling until someone tells me to stop.
Yeah, it seems a bit weird to put calling convention like quasi types into reflection namespace, but I guess that would work. It just would be weird. Or maybe I didn't have enough coffee yet to fully appreciate the creativity of the solution space.
Yeah.
I really like the idea of having a function pointer info or function pointer type info. Just not only does it reduce some of the potential cost in terms of repeated lookup or any questions about that, but it centralizes everything so that you don't need to you don't have to consider that stuff in the future.
Yeah.
If we need to support explicit this or anything else, it can be exposed there and not pollute type.
So Steve, as you mentioned, the original proposal was to have this type, and then per the issue, the type got nuked and all of the methods got moved back to system.type. Is this an argument that you think would be possible to have with the reflection crew and Win, basically, to say reintroduce the type? Reintroduce a function pointer info class?
I mean, if people are leaning towards adding a new type, I went down that route originally, and so did you, Levi. I mean, in the original proposal, and I did like it. I mean, it encapsulates, the methods and the properties that you have. However, we don't do this for other things, and it was pointed out by McCall that we added, I don't know, 5 methods for generics, for example, and we didn't add it, get generic info, and it does complicate type delegation. You can basically have a delegator for type and then do whatever you want, implement certain methods and hide certain methods, that sort of thing. And it complicates that model, although I'm not sure how many people actually use that. So in general, if you have a handful of methods, the thinking was that just put them on type. I mean, that was kind of how it ended up. We've done it in the past. If you need another property down the road, I don't see anything coming down the pipeline that would add any more properties. But I guess if we added a new type of managed function pointer, yeah, then we'd have to add a new, property or method, which, does complicate things. But like I said earlier, I think that it's a case of over designing. After talking to, like,
Well, I mean, Jan mentioned that there's the static managed function pointers and the instance managed function pointers, and if we were going to have is function pointer, is managed function pointer, and then later is instance managed function pointer, it's like that really feels like we're adding way too many members to talk about one kind of type, and that we should have broken it off. It's most of the things on type apply to many of the types. You can have a generic struct and you can have a generic class, so generic being on type makes sense. But you, like, function pointer is a different family of type, so maybe it needs a different family of info.
So if you did, sorry, go ahead.
Was generics also the last time we added a group of methods? Because that would have been 2002, and that was far enough back that I would almost say it doesn't count, because we've significantly changed our stance on how things get exposed in 20 years.
You're not wrong.
There's also the argument for consistency. And also this type has been around though for 20 years, function pointer. It was just never exposed, right?
I mean, if we want to go consistency, we say no to the whole thing, and the consistency argument is function pointers aren't expressible in reflection. So we're changing that. And if we talk about other consistencies, nothing on type has the notion of a return parameter. Like, nothing here is consistent with what's on type.
Right.
Other than is function pointer.
Function pointers are a combination of a type and a method. And so you have some bits of type and some bits of method info expressible on them.
Like, to me, this is the most straightforward solution, especially because it sounds like there's a lot of room for expansion in function pointers. And then now we'll contain it to here. And if you want all these things to be virtual, then sure, I can write the word virtual. But it's...
Don't we have an actual signature type somewhere in reflection?
There is, yes.
Because it seems like this would kind of match that to a large extent, unless I'm missing something.
Signature type looks to be internal.
That's unfortunate.
Saves me the trouble looking it up.
So if you had function pointer info, all of the things on there have to be virtual so that people can write their own delegators. So one of the scenarios for putting them all on type as virtuals is so that you would just get type delegator behavior for free. If you're moving everything onto a new function pointer info type, then all of the members on function pointer info likewise have to be virtual, so that you can write your own delegator on top of it, because that was one of the scenarios that came up. I don't think we need a function pointer info delegator specifically as a new type, because we don't have one for, say, parameter info. But
so why would you need that? Like, if I can construct the function pointer info and I can control the instance, right now it doesn't have a constructor, right? But presumably it would have a constructor that allows you to pass all the data in. Then that's your indirection, right? You need to set this one method, you construct it, and then you put them wherever you want.
It's generally speaking in reflection, you're responsible for providing the entire implementation, which means that they generally subclass rather than have you, construct types with everything specified. It also means that we can add new members in the future.
So that means you would have a parameterless constructor that is protected, and then people would just derive from that and do whatever they want.
Correct.
Yeah, and that also means that they would have to implement all of these methods themselves, versus just overriding, the one that they might be interested in, for example.
Yeah, which means these are all abstract, not virtual, but yeah.
Well, but that's not, isn't reflection mostly virtual? I guess it is, but I mean, the question is, what is
not
the
all of
default
it.
behavior? I mean, I looked at parameter info, for example, and everything, it was non-abstract, right? But I don't know what it means if you just
I feel like they're mostly
derive and
virtual
override
throw.
nothing. Yeah, I guess that's what. Yeah.
Yeah, I mean, if the delegation-y thing is real and matters, and it makes more sense to put it on type, then I guess if that's the space that we're in. But I think if we were designing this new, we certainly. I don't think we would do any of type how we did type if we were designing it new, honestly. But
And just for clarity, if you look at like metadata load context, right? They don't return the RT, the runtime types. They have their own, metadata only RO types, reflection only types. So they would return a different class that derives from function pointer info or from type. That does kind of tie in with the type delegation thing too. But
yeah, so do we have enough to conclude it, or do you want to go back and think about it, Steve?
Actually, we'll probably need to loop in McCall, because he was the one that really pushed back against it, and after we had an offline conversation, I agreed with his points. So I think we'd have to have another meeting to discuss this. Does anybody outside the reflection team want to be part of that? I'll make sure I include you on the meeting, if that's the case.
I'd like to, Steve. I'd just be curious.
Yep, okay.
And I would also argue, just because I know there's passion here, Tanner and Jeremy as well.
Just small comment. Should that function that returns where it's managed function pointer, would it be better if it's opposite, if it's is unmanaged function pointer? Because usually unmanaged things are special. So just,
done.
Yeah, I think is unmanaged function pointer is better, because then that implies that get function pointer calling conventions might give you back useful information, at least nowadays. And if we extend things later, then we would just say it'll give you back useful information whether or not it's true.
Jeremy, the function pointer parameter info type should be abstract. All the members should be abstract. There's literally no virtual implementation we can give you for any of them.
Okay, I mean, like, again, so asking for consistency with the stuff that goes on in reflection, I feel like they're mostly virtual throw.
So type itself is abstract, but all of the virtual methods call abstract implementations. So you still have to override things like type.getProperties, for instance, eventually calls an overload of a method that is marked as abstract. Like,
okay.
There's a lot of abstract stuff in reflection.
Okay. Why was owning type presented as we could add this, but we're not?
It was just an ask that we have the metadata there to add it if we want. Is it important, I guess? Should we add it now or should we add it later? If we add it now, it may or may cause issues down the road, that's all.
Okay. I mean, really,
It was just a way to go back to the type, that's all.
Yeah.
Yeah, and if you're walking the type hierarchy, you have that information already.
I mean, it is something you should make up our mind, though, because it seems like adding this later will be very difficult, right? Because once you already have other people extending it, then you have to deal with the fact that some people may not have provided it, right? So
yeah, well, it's also one of those things where I think in the regular reflection stack, if you consider parameters right now, like regular method parameters, they are individual tokens and map back to individual methods. Like, pretty sure that's not the case for arbitrary signature pieces, like within function pointers.
Right. Like, does a parameter info map back to the member or method info that declared it?
It
Yeah,
does,
I think
yes.
it has member. So it feels like the reflection space is usually a bidirectional graph.
It is, but that's because the way that those are represented in the actual IL or in the actual DLL is that parameters are themselves their own individually recognizable tokens. Like if you have a method, if you have foo of int and bar, that takes an int, like those two parameters are represented in the metadata differently. They just have their own unique identifiers. That's not the case here. Like if you have two function pointer signatures, delegate managed int, delegate unmanaged int, like those two first ints are indistinguishable from one another. They're just encoded the exact same in the IL. There's no
when you say they're
tokenization.
encoded the exact same in the IL, does it mean the second one, like that it defined a, parameter info 127 and they both say 127? Or is it that they both say int?
The IL literally contains something that says like there is a parameter here, it is a type int. There's no unique identifier that maps it back to anything else, and so on.
Right, but I don't think the
understand
IL
how
for
that-
a method parameter is different either. It just says I'm an int, and you happen to know your context
No,
when you're reading
so
it.
it doesn't just say that. Like it also says, by the way, like here's the token that represents the parameter itself, I believe. Someone correct me if I'm wrong, but I'm pretty sure there are tokens there.
No, I think you're right because keep in mind that so a parameter in IL, right, has a name.
Yeah.
It can have custom attributes on it, right? So it's an individual table that you can have more data onto it. So that table row has an ID, which is the token, right? But
Yeah.
I feel like to me the question really is like, is that a meaningful distinction to say you can go back up or not, right? Because I mean that's kind of independent of that question, right?
So the interesting thing about parameter info is even if we didn't have a declaring member on parameter info, there is still a way to get that information because parameter info has a metadata token, which you can then feed back into reflection and say, please
Sure.
give me the member that this token belongs to. And it would allow you to map all of that back. This would not.
Yeah, because it's just effectively like it's just data that floats by itself, right? As part of the signature. I mean,
yeah, function pointers are standalone, and there's no aliasing today, but the language team I know was discussing that.
I mean,
that
honestly,
said,
like,
yeah.
I mean, I don't see a need to walk back up, to be honest.
Yeah.
Like for methods, maybe to declaring type, but once you're processing a function pointer, like, do you really care that when you're like in the third parameter of this thing, like, oh, I forgot which function pointer I was on? Like, I mean,
So that's an interesting question because does it mean position also goes away? Because if there's no back reference to the original function pointer, who cares? Like the position is the index into the array.
Exactly. I was going to say, to me, the fact that position's on it means you should be able to walk back up.
Yeah. If we remove position, like that also potentially allows us to start caching parameter infos and to say like every int parameter info with no modifiers is completely indistinguishable from every other int parameter info with no modifiers.
Yeah, I mean, that's not a bad idea.
Like now we literally just return sentinels back to you and say done.
I mean, it seems reasonable, right? Because I mean, I have a hard time believing that you would extract the processing of the parameters in a separate method anyway. You would probably do it inline in your for loop, right? And so at that point, you clearly have everything.
Yeah, I agree. So I think we either add owning type and keep position or remove them both.
Yeah. Yeah, they really need to be put in or killed together, I think. Jeremy likes hitting backspace.
Less is more.
I agree. So are we saying now we will not do the separate type, or are we saying like there's more thinking offline?
It sounds like from the way that the metadata load context and stuff works that adding the type while it makes system.type have, I think, cleaner surface, that it complicates the world of everybody who has to work in this space. So
right,
if reflection really wants to flatten it. System.type's a big mess. The only thing I really care about is these things not being properties.
Sweet. And so then is unmanaged function pointer is also reasonably cheap? I thought the impression that that was a bit more expensive to compute.
You can look up is function pointer, which is cheap.
Yeah,
or
I think it's
if you just want to, or if you just want to know if it's a pointer at all, is pointer.
yeah, it's this.
No, I meant like so my understanding was is pointer and is function pointer is cheap, but is unmanaged function pointer may not be cheap.
So you're saying it should be a method if it's not cheap?
Yeah, I mean I think Jan said earlier that it's not super cheap to produce that.
I mean, the cheap. If you need to know it, you need to know it. The runtime type could certainly cache it. So like it feels like it's a lazy initializable value, but
I mean that's true, but I mean lazy is only amortized if you expect it to call it a lot, right? Or multiple times. If you only ever call it once, then every access is going to be expensive.
sure. But if you were going to call it once, if you only ever call it once, it doesn't really matter if it's a function or a property.
So this does lead people to use is function pointer, versus
Fair
having
enough.
two methods. And I think it's going to be a super edge case to call is managed.
I think I understand your argument. No, yeah, it makes sense as a property.
Yeah. So it's if function pointer or not is interesting, then is function pointer should be the your precondition. If you actually care if something's managed or unmanaged function pointer, then now you need to go down that resolution pipeline and ask both questions to understand which universe you're in. So you'll need to pay the expense anyway. And if the RT type remembers the answer, then at the end of the day, it was computed once and we don't care.
Yeah. I do like the hierarchy that this gives. Like, is pointer is more general than is function pointer is more general than is unmanaged function pointer. Like as you go deeper down, like you're narrowing what the answer is.
And each one expects pop a token out of it. If this is true, then this is true, and if this is true, then this is true.
Yeah, I do also like the idea of is pointer returning true rather than false, because like function pointers aren't useful for their values, they're useful for dereferencing what they point to, just like regular pointers. It's just instead of dereferencing data, you're dereferencing like the CPU's execution pipeline at that address.
All right, are we happy? So we added info, we changed some properties to methods.
Looks beautiful to me.
The names here seem reasonable enough given where we are. All right.
Why is reflection always so ugly? It's fine.
To tell you that if you're using it, you're doing something wrong.
I guess.
Paste that before I lose the clipboard.
I think you had 4 backticks at the end. Not that it matters, but
Remember, Steve, to also update type delegator when you're doing this.
Yes, okay.
oh, one question I had is because Jan brought it up earlier. Are we doing anything for reflection emit to support function pointers?
That's on the list of to do. Since this is kind of a standalone feature, we wanted to get this in first.
And remind me, like the reflection emit types, aren't they derived from those? Is type builder derived from type, or are they completely different?
I'm not sure following.
So, like the reflection types, right? They have these builder types, right? Parameter info builder, type builder, right? Are those types derived from the reflection types, or do they have their own little hierarchy? So, in other words, like, is any of the things we do here, do we have to consider what it means once reflection emit is deriving from those?
Yeah, I should take a look at. I know we talked about the actual end method when you call like create delegate at the end of IL emit, at least for dynamic methods anyway. that we would need a new method called, create function pointer. Yeah, whether we need a different parameter builder type, I don't know. I mean, I can look right now and figure it out. But...
Yeah,
Yeah, we
because
have to do it right
I
now.
remember us talking about this, like saying how do you just fabricate out of whole cloth a brand new shape of a function pointer.
Yeah, I just want to make sure that every decision we're making today doesn't make reflection emit worse.
I think it would.
This is in the book, famous last words. There's no way this could screw this up. Oh, damn.
Well, so an interesting thing about function pointers as opposed to regular types is that they're also, let's call them fungible. So if I have, if I write in my own code, hard-coded type of delegate star managed int, for instance, and I also use some theoretical function pointer builder to say I'm defining a new function pointer. It has one in parameter that's an int, its return parameter is an int, it's managed, and it has no other calling conventions. Once it fabricates that type, that is literally indistinguishable from the thing that I hard-coded earlier, type of delegate star managed int. Because again, a function pointer is just a signature. And if the signature blobs are the same, which they would be in this case, then the function pointers would, the types are the same rather. So that would be the only complication that I can imagine from RefiMet. The fact that they might need to, when you create a type, you might need to actually return something that already exists within the runtime rather than a brand new type. Hopefully that made sense.
Sort of. I mean, I mean, what do you mean by brand new? I mean, the function pointers do not have names, right? They're literally just signatures, right?
They're just signatures, right? And that's the thing, right? So if I use Type Builder right now to create system.int32, I can do that, right? But it's going to be like an actual different type from type of int because it's going to be in like a different assembly, all that stuff, right? Different metadata tokens. If I create a type, which is a function pointer, and I say, again, like a function pointer is defined kind of like a black hole, solely by certain characteristics that it has, right? Those characteristics are managed versus unmanaged, calling conventions, and the number and types of parameters, and any modifiers those parameters have. If I call create function pointer twice, passing in the exact same arguments to both of them, like, I should get back the same type.
Is that true? I thought the semantics of reflection was that you can have different instances, but they can be the same type. Didn't type have this super convoluted, like equals does something different from double equals, and that was one of the things that they handle differently?
It had like type equivalence, if that's what you're thinking.
No, I mean the operator equals.
Yeah.
And the dot equals method do not do the same thing. And I think one of the things they do differently is basically how they consider identity. Like if you can have the same type but different instances, or it was something like that.
Yeah. And I'm saying like if RefiMet for whatever reason does fabricate actual different object instances, like they would have to figure out how to equate these two back to things that already exist.
Right. I mean, my logical model is that a function pointer would be effectively compared by byte sequence, right? So yeah, you can have two different instances, but they're considered the same type, so it's fine. But we would not have to, ensure they're singletons in reflection emit. We can just give you a new instance every single time you manufacture one.
That's fine.
I did have an equals and get hash code method for a while, and then I removed it because I didn't think it was necessary. And the feedback was that it wasn't necessary.
Yeah.
But we can revisit that.
Yeah.
All right. Do we have anything more on this?
Not more that I want, but there's probably going to be more once Steve does some thinking.
Sure.
Yeah, one of the problems maybe here is that the implementation is not far enough along to know about all of these. So I'm in theory I might have to come back and ask for a change or a new method or something like that. New type.
All right.
Just say you like coming to API review.
Yeah. This looks short, so I'm being
Approve it.
optimistic. Add remaining APIs to complete native memory set 69606. Apparently we want to rename zero memory to clear and then add fill and copy. And
I
why?
notably
context
zero or
copy.
10 otherwise, yeah.
Yeah, notably copy has source first, not destination first. That matches what we've done for other managed APIs, but not what native memcopy does.
Yeah.
So
We also decided to drop memcopy since Levi mentioned it could be potentially like undefined. So we just went with memmove and that mapped to copy, which is what we have right now for like spans and whatnot. And we also dropped memcompare since Jan mentioned it was likely not really that necessary. So we can just reconsider that later on if needed, but it's out for now.
So
The difference between memmove and memcopy being that the one that we went with has well-defined behavior for overlapping buffers.
Right. So, when I remember correctly, when we designed native memory, it was kind of the idea that we align the naming with the C runtime. Are these C runtime names? They're more like .NET names, right? Clear, fill, and copy.
That was one
Yeah,
of the points of discussion, yeah.
Yeah, it would have been set, copy, and or move, and there isn't a clear. It's memset 0, and the Windows name for memset 0 specialization is zero memory.
I see. So zero memory is really more like a Windows than a C runtime thing then?
Yeah, and Jan and others later down in the issue here suggested that we just align with the managed names and do clear, fill, and copy, and those will be intuitive enough to people familiar with the C concepts. There's a few places where there's Windowsisms already, like we do alloc instead of we do alloc instead of malloc, and we do aligned alloc and other things where it's alloc aligned in native. Or
Oh,
vice
calloc
versa.
zeroed instead of calloc. Yeah.
Yeah.
How is this API different from buffer memory copy then?
Buffer
Takes
memory
one
copy
few-
take. Yeah, it takes it. So it takes long and you long, and that's probably not what it should have taken.
Oh, I see. So this one is just different types. Basically, it takes the native ins rather than the.
Yeah, and centralizes it in a place that makes sense with the other APIs exposed here.
Fair enough.
Yeah. If we had Tanner around to wrap us on the knuckles with a ruler back when we did system.buffers, I'm sure we would have done the right thing then.
Yeah, I mean, the proposal looks reasonable. I guess we don't really care that people from languages that don't recognize NUNs can call this. So.
Well,
I mean,
the-
these already take pointers anyway, so.
Yeah, and
Yeah, fair
the
enough,
big
like-
languages can handle it already. F# fully has support for native ints.
Makes sense.
Quick question about like if we have overlapping buffers here, what will we do?
It
For
does
copy,
the correct thing.
Yeah, it's implemented by memmove, so it will do the right thing, like Tanner said.
Sounds good.
By the way, today's span of t.copy2 does the right thing with overlapping buffers as well.
All right, so we got on this one.
Buffer.copy might even do the right thing today.
Buffer.block copy, you mean? Or buffer.memory copy?
Buffer memory copy, I'm pretty sure does the right thing today.
Yeah, I think it does as well. I think we've implemented all of them to have well-defined behavior in the face of overlapping.
Yeah.
All right, we're at time. It seems like we literally filled the 2 hours. It was
Yeah.
kind of depressing. I was really hoping we would get more in the backlog stuff,
Well.
but hey.
Tuesday.
This one's super cute, and I want to claim we did one thing that wasn't read. Yeah, I care, and I chair, so I extend. On the PIM encoding class that we added in 6, we have PIM encoding.write, which returns a char array. We've since added places where we use string, so we have to write this nonsense. And instead of writing this nonsense everywhere that does it, we think that we should just add PIM encoding.write string that does this nonsense for you.
What?
Why would we call it write string rather than something like get string?
Because write, or we already have write, which takes these same 2 parameters and returns a char array.
I see. So for some reason we went with write on this whole type.
Yeah. Because it's this.
Because the crypto we didn't care enough.
Yeah.
Yeah. Okay. Fair enough.
Well, because we started with, with try write, and then we added the allocating returning write, and so now we need the overload by return type, which we can't do. So write string.
Fair enough. Yeah, seems reasonable to me, unless somebody has an objection to this.
Since it's only one API that has the bad name, maybe we should just call it getString and have the character array 1 be the bad name that we.
And I don't make it complicated.
Because I'm going to see this. I'm never going to use this API, but if I ever saw it in code, I'd be like, oh, it's writing to one of the spans that you're inputting.
You know.
Yeah, I agree that
also
write's a
never
bit
see it in
weird.
code.
But, yeah.
Spanifying and strings are hard. All right.
I mean, yeah. I don't care enough, I guess.
Yeah, so we got through all of the reds that aren't dedicated reviews, and I skipped one non-red because it was longer.
Yeah, makes sense.
Yep.
And so there, we got to a non-red item today.
Right. Oh, and I have the first 2 non-red items. Awesome.
Or no, until somebody marks other items.
Yeah.
Yeah.
Um.
All right. So does anybody have anything else they need to say before we adjourn?
No. It was nice not having to host.
Yeah. I don't. Tuesday's not a weird day, right? Like Monday's a holiday, Tuesday's normal. We don't have a short session. Yeah,
I think so.
All right. So, we're over time, meaning it's lunchtime here in Redmond. Well, I'm not actually in Redmond, but here in U.S. Pacific. And so we'll see everyone 10 a.m.-ish Tuesday Pacific time. Ciao.